onto this graph, we just select the data, we add another series, I would just call this the CAL. The X values, we need one more point. Let's copy these two right here. See that when I pasted it there, it pastes the formula. It's not what you want, so. All right, so we need 2 points to make a line. This is 1 point, which is going to be the market basket or the optimal risky portfolio. The other one is going to have a 3% return and 0 risk. Select data, add a series, capital allocation line. X values are our standard deviations. Y values are our returns, and this will be easier once you kind of see it this way, once you get the 5 assets. So that's what I'm looking for each case. Basically, find the efficient frontier, and then find the portfolio with the steepest Sharpe ratio. The next part, all right, so that's A, B, and C.
Whoa.
Comparing the optimal risky portfolios from A and B, what is the estimated?
Yeah, it's chewing up my memory. It ran out again.
Recommendation is outstanding.
What about it?
No, hope it's not recommendations outstanding for Excel and stuff.
What are these two are easy. Okay, so D and E are just to check if you have the right thing. So when you go back in, you're going to say, comparing the optimal risky portfolios from A and B, what's the estimated? Right. You're going to have the optimal risky portfolio. You know that in this case, this one's a 9%, 9.1% expected return with a 15% risk. On the other optimal one, it'll say, here's a whatever percentage return should be higher with a less risk. And so you're just going to tell me the difference in the standard deviations. That's pretty easy. The other ones, what's the portfolio weights for the expected return of 8%? Just list them. It's fine. So now you're done with that part. The next part of the project, we haven't even touched yet, but it's not that bad. So I said. Okay.
So we're not doing
How many
the other
people
part
feel
today?
worse about Solver after what we just I would too. All right. The idea is this. It's not actually that bad. Leave all these blank. Right? Leave all of these blank. Have a working line. Go into Solver. When you're doing this, go into Solver, select your standard deviation, leave everything else the same. The cells you can change are the weights. You just have to make sure you have the right formula.
You need minimum value, right?
You need minimum standard deviation, yep, thank you. And you add in the constraints. The first constraint is no short selling, so all of them are positive.
This is part B.
Yeah. And the total weight is equal to 1. Okay? Then all we do is we specify our expected return. Our expected return is already a formula based on the weights. It's a weighted average using these weights. And then we just say a number. So we already had, say, 13, so we'd say 0.125. Got them all in there. Solver found a solution. Now, the most important thing, and one of the reasons why it's nice to kind of work in a group, is that when you're doing this and you are blinded by after entering all of those it's nice to have another person have eyes on your portfolio, your formulas. All right, so just do this all the way down to say 5% or 5.5%. Then you'll have the efficient frontier. You'll graph the standard deviations and the expected returns. Have the efficient frontier. Put in a Sharpe ratio. This will actually probably work. Maybe. So Sharpe ratio would be equal to the expected return, right? Expected return minus, and by me doing this, you probably actually get a C, the correct answer. If what I do is considered correct. Also, this will be a good talking point. Now, when we're changing this, we don't need the expected return. So all you would do is you would come in here, you would delete the expected return, the other ones stay the same, the weights stay the same. Now you want to maximize, and what you want to maximize is our Sharpe ratio. Fingers crossed, I don't want to look like an idiot twice and probably like 5 times.
This is C.
Yeah. Okay, so solver finds an optimal solution here. Now, what you can see then is that this is the Sharpe ratio, right? This is the Sharpe ratio for a 5-asset portfolio, where the Sharpe ratio for a 2-asset portfolio is 0.4. So the benefit by adding 5 assets as opposed to 2 assets is you have a much steeper portfolio. And what this is going to look like, so that you'll have some kind of comparison. It's going to look something like this. Okay? It's going to have the same minimum point because the least that you can be in there is the all-in bonds. And all-in bonds are the same for both of them. But what you're doing is you're shifting the whole portfolio to the left. The whole efficient frontier to the left. And that's what creates a steeper Sharpe ratio, steeper slope. So the benefit of diversification is you're kind of extending out that curve. Does that make sense? So, if yours doesn't, I mean, it's not going to be this steep. Let's see. It's going to be like this. Oh, that's pretty good. It's going to be something like that. All right. I would say get started on the first part. All right, some other things. Who's done regression in Excel? Take note of people with their hands up. Join their groups. Yeah.